We now move to application of differentiation. Before that, under application of differentiation, we have first one we have concept of maximum and minimum. Under concept of maximum and minimum, we first talk about stationary point. Now the definition. If they say that a point is a stationary point, from the word stationary, something that is not moving. So it simply means if the derivative of a function is 0 at a certain point, then that type of point is what we call stationary point. We say that a point s is equal to a. This point is called a stationary point if the derivative of f of s at s is equal to a is 0. What that simply means is that a point at which the y ds is 0, that type of point is what we call a stationary point, or we call it turning point. He said that we call it stationary point or turning point, something like this. So this is a turning point. At that point, the y ds is 0. Now, in order to find stationary point, we only need to differentiate the function, then we equate that derivative to 0. For instance, now we have to find stationary point of this function. To find the stationary point or the turning point, the first thing is I will differentiate. I'll find the y ds, and if I differentiate x squared, I will have 2x plus, if I differentiate 2x, I will have 2. If I differentiate this, I will have 0. So this is the differentiation. To find the stationary point, I will just equate this thing to 0. I will just say that 2x, that's my answer, is equal to 0. From this place, if you take this to the other side, we have minus 2. So if you divide both sides by 2, then s is equal to minus 2 over 2, which is minus 1. So this s is equal to minus 1 is our stationary point. That is how to find stationary point. You only need to differentiate, then equate it to 0. Any answer you get there is a stationary point. So therefore, our stationary point is minus 1. We can now move to concept of minimum and maximum. How to find minimum and maximum. So let me see how to find minimum and maximum point. The first thing is to find minimum and maximum point. We only need to consider these two steps. The first step is we find the stationary point that we explained there. And how do we find stationary point? Find the y ds, equate the y ds to be 0 so that you get the value of x. That is how to find stationary point. The first step is find stationary point. The second step is differentiate the function once again. For instance, now here I'll differentiate once again. You differentiate the function once again. So that is, you need to find this sign d square y over ds square. It simply means second derivative. That is, you differentiate dy ds once again. So that is what they mean by d square y ds square. So having done that, we can now move to how do we now find the minimum and maximum. If you have followed these two steps, then you look for the condition. These are the conditions here. The first condition is that second derivative that you find, if it is less than 0, that is, if it gives you negative, that is, that second derivative if it gives you negative, then that stationary point that you found here, this stationary point that you found in this step 1 here, so we say that that stationary point is the maximum point. And if the second derivative is greater than 0, simply means it is positive. Then that stationary point is called the minimum point. While if that second derivative is equal to 0, if it gives you 0 directly, then we say that the stationary point that I found is what we call point of inflection. Now let's take example to buttress this. Example 2. Find the minimum and maximum points and minimum and maximum values of this function. You observe that we are finding minimum and maximum point, minimum and maximum value. Now the first thing, to find the minimum and maximum point, find the stationary point. That is, differentiate this. If I differentiate that, I will get 3s squared minus 12. That's the first step. And for this, we will equate it to 0. So that we have 3s squared minus 12 is equal to 0. S squared minus 4 is equal to 0. We have divided both sides by 3. 3 can go in 12. 3 cancel 3, we have s squared. 3 cancel 12, we have 4. Then s squared is equal to 4. We take minus 4 to the other side, so that s is plus or minus square root of 4. When this square comes here, it becomes square root. So our answer is plus or minus 2. So what we have found is our stationary point are plus 2, and the second one minus 2, plus or minus 2. So those are the stationary points. Now, how do you now know whether these two stationary points, whether they are minimum or maximum? We don't know. We now need to differentiate once again. Step 2, we differentiate once again like this. This is our first differentiation. Our second differentiation is you differentiate this once again. That is the meaning of this. And that will give me 6x. If you differentiate 12, that is 0. Now, let me test this. You substitute these values. We substitute these values. If we can't know whether this thing is positive or negative. We don't know. Let us just substitute these values. If I substitute, I'll first say that if s is 0, what will happen? That second derivative will be equal to 6 times 2. We put s to be 2, and that is 12. You see that it is greater than 0, or we say that it's positive. And we say that if the point is positive, therefore that stationary point s is equal to 2 is the minimum point, because it gives second derivative gives me positive. We test the second one to this one. We say that if s is equal to minus 2, the second derivative is 6 into minus 2. So our answer is minus 12, which is, this one is less than 0, or we say that it's negative. Minus 12 is negative. Therefore, we can now say that s is equal to minus 2 is the maximum point. But what they ask us to find, we have to find minimum and maximum point, which we have found. The minimum point is 2. The maximum point is minus 2. Now the second one says find the minimum and maximum values. If they say that you find the minimum and maximum values, you now substitute these 2 points inside the given function. So we continue. We say that our given function is y s cubed minus 12s plus 3. Now let me find minimum value. Minimum value will now be equal to, anywhere I see s, I'll put it as 2. Why do I put it as 2? Because s is equal to 2 is the minimum point. So we use minimum point to get minimum value. So 12 into 2 plus 3. So 2 raised to power 3 is 11 minus 24 plus, this is 8 plus this 11. 11 minus 24, we have minus 13. So the minimum value is minus 13, which we can write as 2 comma minus 13. So the next thing is maximum value. We know that s is equal to minus 2 is what? Maximum point. So I only need to substitute. Whenever I see minus 2, I'll put it here, so that we have minus 2 cube, this one, minus 12 into x, which is minus 2 plus 3. So our answer is, this will give me minus 8 plus 24 plus 3, and that will give me 19. Therefore, I can say that maximum value is equal to 19, or I can write it as minus 2 comma 19. So this is the minimum point and this is the maximum point. 19 is maximum value. So let's take another example. Another example, determine the minimum and maximum values of this curve. Now, to get that, our first thing, we differentiate the y dx. And if I differentiate s cubed, I will have 3s squared minus, if I differentiate 6s squared, I will have 12x plus, if I differentiate 9x, I will have 9. But if I differentiate this, I will have 0. So in that case, that's the first step. Second step is we substitute, we equate this thing to be 0. Now, observe that 3 is common to this. So if I cancel this, I will have s squared minus 3 cancel here, we have 4s plus 3 cancel here, I will have 3, which is equal to 0. So this one leads to quadratic equation. Now at this level, I don't think I should be explaining quadratic equation for you. When we solve the quadratic equation, we are going to have that s is equal to 1 or s is equal to 3. That's the solution of this quadratic equation. So this s is equal to 1, the stationary point are s is equal to 1, s is equal to 3. Now out of this stationary point, one is minimum point and one is maximum point. So we don't know. How do we know? We differentiate once again. We find this, the square y dx squared. If I differentiate once again, let me just, this is the first differentiation. It is this one that I'm differentiating once again, and that will give me, if I differentiate this, I will have 6x minus, if I differentiate this, I will have 12. Now, as usual, I need to test this one, whether it will give me negative. I'll start by saying if s is 1, the square y dx square equal to, anywhere I see s, I'll put it as 1. This is 6 into 1 minus 12. This is 6 minus 12. This is equal to minus 6. This is less than 0. So you observe that we have negative here. Therefore, I will say that s is equal to 1 is the maximum point. Also, if s is equal to 2, the square y dx square is equal to 6 into 2 minus 12. So if you put this, sorry, all we have there is not 2, it's 3. This is 3. 6 times 3, 18. 18 minus 12, that is 6, is greater than 0. Therefore, s is equal to 3 is the minimum point. Because s is equal to 3 gives me positive here. S is equal to 1 gives me negative. That is why this is maximum point. But that's not what they ask us to find. What they ask us to find is maximum and minimum value. Now let us now find minimum value. So we use minimum point. These are minimum point to get minimum value. And how do we get it? We substitute this in the given function. This is the given function. So in that case, our minimum value will be equal to, we'll be using the function s cube. That will be 3 cube minus what we have there, 6 into 3 squared plus 9 into 3 plus 1. You come back to your function. Anywhere you see s, you'll be putting it as what you got. So if I simplify this now, this is 27 minus this plus another 27 plus 1, it will give me 1. So in that case, our minimum value is 1. So which I can write as 3, 1. Also, the maximum value. So we got that using s is equal to 1. Because s is equal to 1 is our maximum point. So we are going to substitute inside that place. So our y is equal to 1 cube minus 6 into 1 square plus 9 into 1 plus 1. Anywhere you see s, I'll put it as 1 here. So when s is equal to 1, I have 5. In that case, the maximum value is 5. So which I can also write as 1, 5. So this is the maximum value, and this is the minimum value of that function. This is another example here. Find the minimum, maximum, and point of inflection of this curve. Now, I will only need to video it, then you study it. This is the solution. Study it is very, very important. This is the solution. This is the continuation. This is the continuation. This is another interesting example. An open rectangular tank of height h meters and volume 36 meter cube is to be of sheet of iron. If the base of the tank is of dimension 2x by x, find the values of s and a so as to use minimum amount of sheet. They are talking about surface area of this tank, and since they are mentioning minimum here, so it's application of minimum and maximum values. But firstly, let us draw the tank, the rectangular tank they are talking about. The rectangular tank, they have told us that the base of the tank is 2s by x. That is, this place is x, this place is s. So definitely this place will be x, this will be x. It is of height h meter. This is of height h meter, height h. So, but in this case now, we have been told that it is an open rectangular tank, so there is no surface here. So in this case, let's first talk about the volume, because we are given volume here. We know that volume of a cuboid is length times breadth times height. And what is the volume in that question? The volume is 36, which is equal to length times breadth here is 2x by x by height. Height is given as h. From this list, if you make h the Zeller formula, h will be equal to 36 over this, which is 2s squared. Our answer is 18 over s squared. We have known our h. Now, we know the surface area. We know that surface area, or simply area of this shape, will just be area of this base. An area of the base will be 2s into x. Area of this base, there is no base on top, plus area of these two. This one, area of this rectangle is s times h. There's another one facing it, it will still be s times h. Also, area of these two on the other side will be equal to, plus 2s times h and 2s times h. So that the whole thing will just become 2s squared plus, if you add all this together, this will be 6sh. But we have done our h here. H here is 18 over s squared. Finally, our area there, or surface area, will be 2s squared plus something we cancel out. When we cancel it, we are going to have 108 over x. 6 times 8 is gone, is 108, s cancel s. Now, we are not talking about minimum amount of sheet. Now, to find minimum, we differentiate. If I differentiate, it will give me 4x minus. If I differentiate this, it will give me 108 minus s squared. Because we know that if I differentiate 1 over s, I will have minus 1 over s squared. So in that case, what's the next thing? We normally equate it to 0. We normally say that 4s minus 108 over s squared is equal to 0, which means 4s is equal to 108 over s squared. Let's cross multiply. Also, 4 will cancel 108, so that we have s cubed equal to 4. If this 4 in 10, we have 2. It will remain 2. In 28, that is 7. So from this way, you see that s is equal to 3. So s is equal to 3 is the value of s that will give me minimum amount of sheet. So if I have found the value of s, they ask me to find the values of s and the values of h. So I don't need to open to another page. I can find h directly here. H is 18 over s squared. 18 over our s is 3 squared. This is 9. And 18 over 9 is 2. That means h is 2, s is 3, h is 2. I can say that s is 3, h is 2. That completes the solution. Let's consider this question. Example. given a rectangular sheet of metal 8 by 5 meter, 4 equal sides are removed from each of the rectangular corner. Let's start from that side. We know this is a rectangle. They said the rectangle is 8 by 5, and they said that 4 equal square are removed from the sides. So this will be x, this will be x. Because it is square, they will be equal to each other. Let's say that they are equal to x. This will be x, this will be x. So definitely the remaining one here will be 8 minus 2x, because the whole thing from this face is 2x, is 8, but I already cut out one x here and another x here. So this place too will be 8 minus 2x, while this one too, the whole thing before is 5. This will be 5 minus 2x, because the whole thing is 5. Definitely this one too is 5 minus 2x. Now, what did they say again? They said, and the edges are turned up to make an open box of volume V. Show that the volume is this and find the maximum volume the box can have. So what they are now saying is that this thing is used to form a box. What type of box can it form? So this is it. You can see this is 5 minus 2s, this is 8 minus 2s. They use it to form a box. So the height of the box will be x, because it is x that they cut out from the box. And how do we find volume? Volume is length times breadth times height. That is this times this times this. Which is this? This one times this times x is this, and it is equal to this. So that is the required question. We are now asked to find the volume, maximum volume. How do you now find the maximum volume? The first thing is we differentiate. You can see we have differentiated twice already here. This is the first differentiation. We differentiated this. If I differentiate 40x, I will have 40. If I differentiate this, I will have this. If I differentiate this, I will have this. Now, the second derivative, I will differentiate this once again. Now, what's the next thing? To find the stationary point, we equate this to 0. That is what we have here. And when we use quadratic equation, we got s is equal to 1 or s is equal to 10 over 3. Solving this quadratic equation. But we don't know whether this one is minimum or this one is maximum. We need to know, because the question says we should find the maximum. So either this or this will give me maximum. So I have to differentiate once again, which I have done here. When I differentiated once again, 2s, 24s minus 52 is what I got. Now, when s is equal to 1, I'm testing it. When s is equal to 1, I got negative. I put s is equal to 1 and I got negative. So since s is equal to 1 gives me negative here, therefore s is equal to 1 is the maximum point. Is the maximum point. But they asked me to find maximum volume. What will be the maximum volume? I'll substitute this s is equal to 1 inside the given function. This is the given function that we got. That will be 40 into 1 minus 26 into 1 plus 4 into 1 cube. That's what we have here. So our answer is 18 meter cube. So that is that about that. So take this as an assignment. This is an assignment. Solve the same question. Okay. Well, solution is there. Solution is there. But I don't think I'll stay with the solution very well, so that you won't copy the solution. Okay. Another important application is rate of change problem. So rate of change problem is just like that of differentiation application of parametric differentiation, which we say that if you have dy ds is dy dt times dt dx, if you remember. So this is just the formula that is useful in this place. So which we have here, dy dt is dy dx times ds dt, like that. Now, if they now say that rate of change simply means d dt. D dt means rate of change, or we can say that rate of change simply means change with respect to time. Change with respect to time. It's either we say rate of change or change with respect to time. That is the meaning. So if I say that rate of change of radius, I simply means dr dt. Dr dt means rate of change of radius. If I say that rate of change of area, I simply means dA dt. That is what I simply means. Then with this help of manipulation, we should be able to do something. Now let's take example. Example 1. So this is a question. The rate at which the radius of a circle is increasing is this. Now the rate at which, that is the rate of change of radius, let me put it like this. The r dt, they said is 0.5. They now said that find the rate at which the area is increasing, that is the a dt. That is what I'm looking for. The first thing is that we are dealing with circle there, and we are finding a rate of change of area. I need to first know what is area of a circle. Area of a circle is pi r square. Now if I differentiate this dA dr, if I differentiate this thing, I will have pi is a number, r is a variable. If I differentiate r square, I will have 2r. So our answer is 2 pi r. This simply means that if I differentiate area, I will get, 2 pi r simply means circumference of a circle. That is one of the application of differentiation. When I differentiate area, I got circumference, which is 2 pi r. Now, but what I'm looking for is dA dt. So using the formula dy dt, so dA dt, and A is a function of r, I will say that dA dr times dr dt. Because this, if r dr cancel dr, I will still have dA dt. dA dr, our dA dr is 2 pi r times dr dt is given here to be 0.5 centimeter per seconds. So from this place, what do we have? We have 2 pi times r. We are giving r to be 6 times 6 times 0.5 centimeter per seconds. Finally, when we multiply this together, it should give me 6. Let me leave pi as like that to give centimeter square per second. So that will be the rate at which the area is increasing, 6 pi centimeter square per second. Let's take another example. Another one, the radius of a hemisphere increases at the rate of 0.25 meter per second. If the radius of the circle, not the circle, the radius of the hemisphere is 10 meter, find the rate at which the total surface area is increasing. Now, they have been told that radius of that hemisphere is increasing at a rate. Simply means dr dt is 0.25 meter per second. Now, find the rate at which total surface area is increasing. Let us first know total surface area, or simply area. Total surface area of hemisphere is given as 3 pi r squared. Then we need to differentiate the A, the r, because A is a function of r. The A, the r will now be 6 pi r, and we differentiate. So finally, I can now find, because we have to find the rate at which the surface area is increasing. That is the A dr. That is the A dt. Because that rate simply means over dt. And the A dt will be the A dr times dr dt. So our dA dr is 6 pi r that we got here. Our dr dt is 0.25. So which is equal to 6 pi times our radius is 10 times 0.25. We know that 25 is 0.25 is 25 over 100, or 1 over 4, and that will give me 15 pi meter square per second. So that is that about that. Now let's take another example. That will be example 3. This is another question. You can see the rate of increase of radius of a sphere is this. You can see this is solution. Now study it. Let's take another example. Now we are told that the volume of a sphere is increasing at the rate 40.this meter cube per second. Now let us first deal with this statement. The volume is increasing at a rate, that is the v dt, volume of a sphere. So the v dt is given as 40.8. But we know that volume of a sphere we know that is 4/3 pi r cube. We know that that is the formula of finding volume of a sphere. If I differentiate this with respect to r, because r is the only variable, this is 4/3 pi. If I differentiate r cube, I will have 3r squared. The 3 cancel 3, I will have 4 pi r squared. So from this place, our dv dt, normally it simply means dv dr times dr dt. We are still dealing with this statement alone. Now our dv dt is given as 40.8, which is equal to dv dr. This is our dv dr, 4 pi r squared times dr dt. Dr dt is not given. If I make dr dt the same formula, dr dt will be equal to 40.8 over 4 pi r squared. Now let's take note of what is there. Also, let us now come to the question. Calculate the rate at which the surface area is increasing. What is surface area? Surface area of sphere. We know that surface area of sphere, or simply area, is 4 pi r squared. I need to differentiate this as well, so that the a dr is 8 pi r. If I differentiate, r squared will be 2r. That will multiply 4 to give me 8. But what they asked me to find is the rate. It's rate that I'm looking for. The a over dt. That's what I'm looking for. The a dt is the a dr times dr dt. Our dA dr is here 8 pi r times dr dt. This is our dr dt here. That will be 40.8 over 4 pi r squared. Some things will cancel. 2. This cancels this. So that we are going to have 2 times 40.8 over, it will remain r. This is 2 times 40.8 over r. Our r in the question is 3.2. The radius is 3.2. So I'll come here over 3.2. Then with our calculator, have 25.5 meters square per second. So that is the final answer to this question. Interesting application is what we call radius of curvature, or curvature of a curve. Curvature of a curve and radius of curvature. Now if you get to a turning point, something like this, consider this point, this movement of a vehicle. This sharp corner here, sharp turning here, is what we call curvature. The sharp turning there, we call it curvature. Now if they now say that curvature, so let's say this is a curvature. If I now draw a straight line here, I now use the curvature here to form a circle. If I form a circle from the curvature, we call it circle of curvature, and the radius of that circle is what we call radius of a curvature. So mathematically, how do you find radius curvature? This is the formula of finding curvature. Second derivative divided by 1 plus dy dx all square raised to power 3 over 2. Or we can write it like this. This y prime prime simply means second derivative. And y prime simply means first derivative. This means dy dx. And radius of curvature is the reciprocal of curvature. Reciprocal of this, that is 1 over this. Which means I will turn this upside down. That is how to find radius of curvature. So let's take example. On this, find the radius of curvature of the parabola this at s is equal to 2. Solution: to do this, I will need to differentiate. If I differentiate this function, I will have 2s minus 4. They said at s is equal to 2, so our answer is 2 into 2 minus 4, which is 0. Secondly, I will differentiate once again. If I differentiate this, I will have 2. Then I will now use the formula of the curvature. So if I use the formula of the curvature, we recall that radius of curvature, let me use R, is 1 over curvature, which is simply 1 plus y prime square raised to power 3 over 2 divided by y prime prime. So this is 1 plus y prime is 0. You have 0 square raised to power 3 over 2 divided by y prime prime is 2. So from that place, the whole thing is 1 there over 2. So in that case, radius of curvature here is half. Example 2. Another question: find the radius of curvature of this function at a maximum point. We are not giving point unlike this one that we are giving point, but here we say that at a maximum point, that is the maximum point of this function. How do you find the maximum point of this one? Sine 2s. So we know that sine, it cannot go more than 1. Sine and cos, their maximum, the maximum function of sine is 1. So in that case, the maximum occurs at sine 2s is equal to 1. From that place, if I make 2s 0 formula, I will have arc sine 1. So arc sine 1, that is what can give me 1. What the sine can give me 1, that is 90 degrees. Sine 90 degrees is 1. Or I will write it as pi over 2 under that rig. If you make s 0 formula, we have pi over 4. So pi over 4 is the maximum point of this function. Now, how do we do it? We differentiate once. If I differentiate this, I will have 2 cos 2x. Then I'll put this value there, which is 2 into cos 2 into pi over 4. This will give me 2 cos pi over 2, because 2 cancel 2. Cos pi over 2 means 90, just like what we have here, but cos 90 is 0. Also, we need to find second derivative, that is, I should differentiate this. If I will differentiate this, it will give me minus 4 sine 2x. I will put s to be pi over 4. That is minus 4 sine 2 into pi over 4. This cancel this. What we have left is sine pi over 2. But sine pi over 2 is 1. What we have left is minus 4. So we have found the second derivative. Then the curvature. Let's say we want to find the curvature. The curvature is second derivative over 1 plus y prime all square raised to power 3 over 2. This gives me minus 4 over 1 plus, this one is 0 here, 0 square raised to power 3 over 2. Everything at the denominator is 1, so we have minus 4 left. So in that case, the curvature is minus 4. But I'm looking for radius of curvature. We know that radius of curvature is 1 over curvature. That is 1 over minus 4. So minus 1 over 4. So the radius of curvature of this function is minus 1/4 is the radius of curvature. Another question, find the least radius of curvature of the curve y is equal to x squared. We see solution, first derivative, second derivative. We substituted it here. So study the question. Study the question. So that is that about application of this. We now move to integration.